Alright, hi everyone. We are continuing with our data structures and algorithm series. In our previous video, we looked at our first problem solving pattern that was frequency counters. And today we are going to see our second problem solving pattern that will help us in solving problems with better performance, better time complexity, and better space complexity. And today's pattern name is Divide and Conquer. As its name suggests, we need to divide our data into smaller chunks or subsets. And then we need to apply our logic on that subset to get the desired output. This pattern can tremendously decrease time complexity because we are going to apply our operations on a small set, not on the complete data set. Later on in the series, when we will talk about some searching and sorting algorithms, we will use this pattern in binary search, quicksort, merge sort, and a lot of other algorithms. Now to understand divide and conquer properly, let's look at an example. We have an example here where we need to find index of 4 in the given sorted array. Now remember, if our array is sorted, then in this type of questions, divide and conquer can perform the best. Now let's see how. We are having a sorted array of 5 elements. First of all, I will mark 1 as my minimum and 5 as my maximum because the value we are looking for cannot go behind 1 and cannot go ahead of 5. So I will mark 1 as my minimum and 5 as my maximum. So as we saw in our definition, we need to divide our data into smaller chunks. For that, let's find out the middle point of this array. The middle point is 3, right? So we will divide our array into two parts here. One is 1, 2, 3 and the second one is 3, 4, 5. Now we need to see whether our desired value, which is 4, is greater than 3 or less than 3. If it is less than 3, then we will pick this half of the array, and if it is greater than 3, then we will pick this half of the array. Now since we have to find out our desired value in this part of the array, we need to redefine our minimum and maximum limits. The minimum in our case is going to be 3 now because 4 cannot go behind 3, and the maximum will still remain 5 because 4 cannot go ahead of 5, right? Now we need to repeat our process that was of dividing our array into smaller chunks. To divide this part of the array, we need to find out the middle part. The middle part is 4 now. Let me mark the indexes of all these elements. Now you can see we are having all the indexes here, as we have found out that 4 is our desired value and we can get its index, and that's it. 3 is our answer, right? Now let's see all of this in action by writing code in JavaScript. We will try to solve this problem using divide and conquer. For that, let's move to Code Sandbox. Alright, so I already have a function called search here that accepts array and a number, right? We need to find out the index of this number in the given array. Now let's write code for it. If you remember, during our example, my first step was to mention the minimum and the maximum limit. The number cannot go behind 1 and cannot go ahead of 5. So let's collect our minimum and maximum limits. For that, I will write here let min equals to the first index of array, that is 0, right? And the maximum will be the last index of this array, that is array dot length minus 1. Now as we remember, we need to repeat the process of dividing our data into subsets. For that, we will need a loop here, right? Now what should be the condition we should pass here so that our loop knows when to stop the process? For that, let's move back to the slides. Now if you remember, In every process, we were dividing our array into subsets or into subarrays, and every time we were redefining our minimum and maximum limits. Like here in the beginning, my minimum limit was the 0th index and the maximum limit was the 4th index, right? And when we found out that our value might lie in second half of the array, we changed our minimum limit to the second index and the maximum limit remained 4th index, right? But imagine if I ask you to find index of 6 instead of 4 here, how you will find this? For that, let's see. Now to find 6 in this array, we need to find out our minimum and maximum limits, and that is 0 and 4th index, right? The middle point is 3 here. Now as we know 6 is greater than 3, then we will try to find our 6 in this part of the array. We will take this out and then we will redefine our minimum and maximum limits. Now our minimum limit is second index and the 4th index. Now again, as we know, we need to repeat our process and keep on dividing our array into smaller chunks. Now the middle point is 4 here. Now if we compare 6 is greater than 4, now we know that we need to find out 6 in this part of the array. We will divide it further and then again repeat the process. Define the minimum and maximum limits. The minimum one is 3 here and the maximum one is the 4th index. Now find the middle point of it. Middle point will be 4 in this case. Now if we compare, is 6 greater than 4 or smaller than 4? It's greater than, right? So we need to find out 6 in this part of the array. Now we will further divide it and then we will get 5 here as our last element. Now this is our minimum and maximum both limits. If we compare 6 with 5, we know 6 is greater than 5, right? We cannot go ahead of it, right? So we can simply say 6 does not exist here. But remember, our last minimum and maximum limit was this 4th index. We cannot go beyond this, right? So can we say our maximum and minimum limits can be equal but cannot go beyond of each other, right? So according to this one, our condition should look something like our minimum limit should be smaller than maximum and it can go max to max equal but cannot go beyond maximum, right? If this condition gets false, then our process should stop. Our while loop will break here. Alright, the next step is finding the middle point, right? Now let's find the middle point. We are using math.floor here so that we can get an integer value just in case our divide gives us decimal values. I will write comment here. Our first step, not first, I will say it as our second step is to find the midpoint. Our first step is to find the min and max limits. Our third step is to check if midpoint is our desired value or not. If array mid is equals to num, then we will return the index, I mean the mid value. Now fourth step will be to check if we need to search our desired number in right half or in left half of the array, right? For that, let's write condition if array mid is smaller than num, then our minimum limit will change to mid plus 1. If our midpoint is greater than num, in that case we will change our maximum limit to mid minus 1. And if the num doesn't exist, in that case we will simply return minus 1. Alright, now let's try to run this function and see if we are getting our desired value or not. Now if I uncomment this console log, you can see the index I have got is 3, which is correct, right? 0, 1, 2, 3, that's my index and this is the correct value. If I comment out this one back and uncomment this one, you can see I am getting minus 1, means 6 does not exist here. Now if I change this to 2, I am getting 1 index, which is correct, right? So our process that we see is working as expected. And the time complexity of divide and conquer can go up to, for this case, O of log n, which is better than a naive approach. Naive approach will be to check each element one by one and then give the index. That will have time complexity of O of n, which is not good as O of log n. Alright, so that's all for this video. In the upcoming video, we will see some other common problem solving patterns. Thanks for watching.